Automated testing can provide quite a few benefits when developing software, but unfortunately, many people have a hard time convincing other people to pick up the good habits. If you're in a position where you've reaped some of the benefits of automated testing and you're wondering, well, how can I show other people the value of this? How can I convince other people to get on board with this? You might be tempted to try creating new policies or trying to set standards that enforce people to write tests of the code that they're creating, maybe to even look into code coverage as a means to enforce some policy as well. But I think instead of looking at policies and how we can maybe force people to use testing, I think the best way to convince people and to get people on board and to make automated testing contagious is to show them the value. Demonstrate to them the rewards you've reaped from automated testing, and I think you'll find that they'll quickly be on board. After all, at the end of the day, automated testing is really about something we already do. We already manually test things. Automated testing is just an improvement upon manually doing things. It's not some scary new way to test applications. It's not some scary new domain, though it may seem like that if you're not familiar with it. It's just a new way to do something we've always been doing. What do I mean when I say this is already something that we do right now? I've got this sample application up here, and it's a program that can take some input, and the input is an expression, and it'll calculate the result of it. For example, I could do 1 plus 5, and I could get that the output is 6. So if I'm a programmer and I wrote this software, or I'm helping testing this, maybe I'm a tester, and I want to run through some different scenarios and see what happens to make sure that the application behaves as it should, then as a programmer doing traditional manual testing, first I'll have to come up with a scenario in my mind. Now, maybe I have some documents that list scenarios I should run through, but every time we want to release a new version of the application, I may need to go through different scenarios. And so, for example, let's say I wanted to test addition. Well, I would need to come up with two numbers to add together. So let's just say I come up with 3 and 5. All right, so that's the input to the scenario. And then when I run the program, I get the output. And in this case, I get 8. So then the next thing that I have to do is I have to think to myself, well, OK, so 3 plus 5. Well, of course, the answer is 8. That's easy enough. But I could make a mistake in that process. Since I have to recreate what the output should be, I guess unless a scenario is written down with specific inputs and outputs, then I obviously have to go through the process of determining what the output should be. And in this case, I know it's 8, and I can see that the program returned 8, so I think everything's OK. But I do have to go about creating the output myself, or maybe calculating it by hand, and then verifying that the program gives me the same result. And maybe I need to run through another scenario like -1 plus 4, and I want to see if that's correct. That comes out to 3, so I do the math in my head, and yeah, that seems like that's about right. It's a very manual process. It can take quite a bit of time to do this type of testing. It can be rather repetitive. If I don't have a document listing different cases to go through, I may have to come up with the scenarios to test on the fly as well. As you can imagine, something could easily be missed. So the first thing I need to do when I'm testing the program is I need to come up with an input. This is something that describes the scenario that I'd like to test. In the little application I was just demonstrating, I was adding some numbers together. So for example, I might need to come up with an input where I pass 3 plus 5. I feed that input into the program. In the case of the little application, I hit the return key. That goes into the program. And then output comes out of the program. In this case, the program returned equals 8. And of course, in the manual process of testing, then I have to go and think to myself, OK, 3 plus 5, yes, that should be 8. All right, so things seem OK. So there's a verification step of the output that comes out of the program. Although this works, this process can be rather time-consuming. And of course, as I said, I have to come up with the scenarios, unless, of course, maybe they're written down. And I have to come up with what the output should be. So there's a good chance that I could make a mistake in the process. And of course, this is all tedious. And therefore, it's not much fun. So that's what the manual testing process looks like. This is something we're all used to doing. This is something we have a history of doing. It's something we have to do to make sure that our program behaves as expected before we release a new version of it. But what if we could write some code to do this for us? So what if we could describe our input in this case? And let's use that scenario that we just tested, 3 plus 5. What if we could write down the input that we would like to use? So in this case, we're testing addition. So we'd like to test 3 plus 5. And then what if we could get the output from the program by simply calling the code of the program itself and running the calculation on the input that we provided? And then what if we could take the output and we could say, hey, I expect that the output is equal to, and in this case, 8. So what if we could write this little program right here that describes the input, 3 plus 5. We could calculate the output, and then we could verify that the output equals what it should, in this case, 8. And then what if when we run this, we could get a little green check mark if everything is OK. And then if something's not OK, say, for example, we came up with the wrong expected outcome when we run this, we'd get a warning telling us that there's a problem. In this case, we expected 9, but we actually got 8. Now, in this situation, it was simply that our expectation is wrong. 3 plus 5 is actually equal to 8. But perhaps our expectation is correct, and it's our program that's wrong. So we could go fix our program instead. Or in this case, we could fix the expectation. And then once we fix that, put that back to 8 in this case, and run it again, we get a green check mark telling us that everything's OK. So instead of launching the program, typing in 3 plus 5, hitting return to get the output of 8 in this case, and then verifying that 8 is actually the correct answer, we can write down a set of instructions here, and we can save them away. Now this is testing addition. We could write down another set of instructions that test subtraction, or another set of instructions that test addition with negative numbers. As you can imagine, we could write down a bunch of different scenarios where we test many different parts of our program. Maybe all the different scenarios we'd have to run through every time we test our application before we release it. And then we can take these little scenarios that we have as instructions or code, and we could save them with our application, actually. And we produce like a little run book of tests or a history of tests that we can rely upon. And that's the true power of automation. It's simply that we already do this type of testing. We already do manual testing. And automation is just a means to take the tediousness out of that manual testing and to take out a lot of the error-prone aspects of that manual testing. Essentially, it makes life easier at the end of the day. And if you can demonstrate these benefits, as well as the other benefits that you've reaped to other people that are involved in the process of creating software, whether they're developers or testers or operations staff or anybody involved in the process where they may need to be verifying certain things when the program is updated and the next version needs to come out, then I think you're going to find that they gravitate to these ideas. This type of testing is rather contagious. I mean, nobody likes to sit through and punch in all those commands in a tedious fashion, and that's in a console application. In a more rich application, like maybe a web application, nobody likes to have to go through clicking buttons and navigating around a website to try and reproduce a scenario and see what the outcome is. And as people get more comfortable with this style, they'll find that they can write more tests of what they do, and they can run those tests very quickly, many of these tests very quickly. So they can now start to run through a lot more scenarios every time they want to test the application. So that should boost confidence in the testing that's being done. If you only have a couple of hours for each release of your application to do testing, well, traditionally, maybe you can only get through 10 or 20% of the things that you'd like to test. Now, theoretically, you could get through 100% of the things that you would like to test, or you could get a lot closer to it with whatever you could automate. And then you could take the extra time you have to do some further exploratory testing that you may not have thought of. So if you approach this from the perspective of how will this make your life easier, and how this is already something you do, it's just kind of a new take on it, I think you'll find that people get pretty excited about automated testing.